Hi, looks like you had some problems yesterday. Lots of you wrote to me saying you weren't really sure about what to do on the proportionality stuff. So I thought we'd start again and I'll take you through it from the very beginning. Okay, right back to basics and see if we can get a bit further this time. Okay, so if you put a head in proportionality, and then I put up in the top left here that this is an A grade topic, so it is one of the more difficult, but as long as you can get your head around the steps, the questions are pretty much the same every time. But it's a maths and numeracy topic, so you'll kind of get double points for it. So it's a big one. It's a good one to have in your can do column. Okay, right, we'll start with, and you can pause the video to have a go at this, a simple question about apples. So pause the video, have a go, and then we'll talk about it. When you're done, press play. Okay, for the first one then, because it says what would 10 apples cost, and the original question said 5 apples, you haven't really got to do a lot of maths apart from realise that if you buy twice as many, it costs twice as much, so £4.80. Okay, you don't need to know much else to answer that question. Okay, but for part B it's more difficult, because it says 3 apples, and 3 doesn't go very nicely with 5. The only way you can really answer this is to work out the cost of 1 apple. Okay, and 1 apple is £2.40 divided by 5, which is 48 pence. Okay, which means then you can times that by 3, and 3 apples would cost £1.44. Okay, and then another one similar to that. 4 friends share some money. They each get £15. How much would they have got if 2 friends had shared the money? How much would they have got if 5 friends had shared the money? Give it a go. Press play when you're done. Okay. For part A, you don't need to know how much money there was. If 4 of them shared it and it was £15 each, it makes sense that if only 2 of them had shared it, they'd get twice as much. So they would have got £30 each if only 2 of them had shared it. Now you may have worked out how much money there was to answer part A, but you didn't need to. For part B though, I think you are going to need to know how much money there was. So if 4 friends got £15 each, the total amount of money is £60. And then dividing that by 5, you get £12 each if 5 of them share the money. Okay, and both those questions have got something in common. Part A was easy. You didn't need to know the cost of an apple to do part A on number 1. You didn't need to know how much money there was altogether to do part A on number 2. But for part B, you couldn't answer it unless you knew the cost of 1 apple. And on number 2, you couldn't answer it really unless you knew how much money there was in total. Now, in proportionality, we have something called a constant. So in every question, there will be a value that doesn't change. Okay, and that value is crucial to answering questions. Okay, you're not told that constant at the beginning. So like on question 1, I didn't tell you that 1 apple was 48 pence, but you needed to know it to do part B. And on number 2, I didn't actually tell you that there was £60 in total, but you couldn't answer the question without working that out. Okay, like on number 1, now that you know an apple is 48 pence, you can pretty much answer any question I give you about apples. And on number 2, now you know that there's £60 altogether, you can answer any question about the friends sharing the money and how many friends there are. Okay, because the crucial bit of information in each of those questions on number 1 is what is 1 apple cost, and on number 2, how much money is there altogether. That's what we would call a constant in a proportionality question. Okay. Okay, so let's cover up some of that. You'll need to scribble this down, so if you want to write and talk, and then if you need a bit more time you can pause the video. Proportionality is looking at the relationship between variables, and variables sounds posh, but it could be as simple as the value of a car and how old it is, okay, or the temperature and how many ice creams get sold. You've done something like this before in year 8 when you did correlation, okay, scatter graphs and correlation, looking at positive correlation and negative correlation to see if there was a link between things. Okay, are older people taller people? Okay. Does Tesco's sell more umbrellas the more it rains? Looking for links between sets of data, or what we call variables. Okay. And the example I've got there, when we go to a petrol station, as the amount of fuel we put in increases, so does the amount of money it costs. So what we say is they are directly proportional. Okay, as one goes up, the other one goes up. If you buy twice as much fuel, it costs you twice as much. If you buy half as much as the person next to you, you will pay half as much. Whatever you do to one variable, you do to the other. Okay, and that's called direct proportion. Okay. And then what we have is this little symbol. Okay. And now it's an alpha symbol from the Greek alphabet, and you may have seen that in physics as a type of radiation. But if we use that symbol in maths, what we're saying is that the cost and how much fuel you buy are directly related, directly proportional. If you increase one, you increase the other. Okay? And that's all that little symbol means, is that they are linked. And you can change it just to letters, because we just work with letters rather than words. Okay, this is algebra and equations ultimately. So cost is proportional to the number of litres that you buy. Okay. Now, just like with the apples, if I buy twice as many, it costs twice as much. But what the key information was on the apples was, what does one apple cost? Well, if you go to the petrol station, on a big sign outside it says, what does 1 litre cost? And that's the constant of proportionality. Okay, that's the number that's the key to the maths, that doesn't change while you're filling the car up. That amount, it might change week to week, yes, but while you're filling your car up, that does not change. So if you know how many litres you've bought, you can work out how much it costs. If you know how much you've spent, you can work out how many litres you've bought, as long as you have the key bit of information, which is the cost of 1 litre, the constant of proportionality. Okay, so when you're ready, just move on with me. If you're not ready, press pause and press play when you're ready. Right, now then, what happens in proportionality is you start with this symbol, the little fish symbol. Okay, I just call it a fishy, even though it's an alpha symbol, it's easier to call it a fishy because it looks like a fish. So yes, you can say that they are linked, and yes, you can say if I buy twice as much, it costs me twice as much. But what we would actually prefer is a concrete statement with an equal sign. Okay, and so what happens is the little fish sign at the start, that little fish is replaced by an equals to turn it into an equation, and a k to include the constant. And like I say, when you go to a petrol station to fill up your car, the constant is the cost per litre, the number on the sign. Okay, it's also on the pump. Right, so if we have a look at an example using that, I don't need that bit. Okay. So the cost of filling the petrol tank is proportional to the amount of fuel that is put in, and so C is proportional to L. Make sure you got this in your book. And then I said that you can change the fish sign, this thing, get rid of it because it's a bit babyish, it doesn't really tell us a lot, and we can do a lot more maths if we know this constant. Okay, so there you go. I've given you a statement that if Andy buys 30 litres of fuel, it costs £33. Now from that, what can we work out? Well, if you've got a calculator on you, you can work out the cost of a litre. So in your books then, so the cost is 33, so C is 33. I don't know what K is, it's K for constant, don't ask me why, times the number of litres, which is 30. Now how would you work out K? Well, if you're solving an equation and it's times on one side, it goes to a divide on the other side. So take that times 30, change it to a divide by 30, and you'll get that K equals 33 divided by 30, £1.10. Okay, now most of the questions I'm going to do with you are non-calculated, but you might want to calculate for that one. So what have you just worked out? You've just worked out 1 litre. Okay, now when I give you some more questions to do about this, you can use that information that there's 1 litre to answer these two questions. How much does 50 litres of fuel cost? Well, C equals K times L. It's the cost per litre, £1.10, times the number of litres. So £1.10 times 50 is £55. Okay, the cost is £55. because we know what 1 litre costs. This bit here, that's the crucial bit of information, the constant. How many litres does £100 buy? Okay, well this time, so C is 100, is £1.10 times K. Sorry, not times K, times L. Number of litres is what we're working out, isn't it? So L. So 100 divided by £1.10, this isn't going to come out very nice. 100 divided by £1.10, I'm tapping it in live, is 90.91. So the number of litres must have been 90.91 litres. £1.10 times that number gives you £100. Okay, but again, without knowing the constant, without knowing that it's £1.10 a litre, that would have been very, very tricky to work out. Okay. Now this basically is the topic in a nutshell, and you're going to want to get this in your books, because if you follow these 5 steps, you're going to be able to do every proportion question on an exam. Okay. The first bit is usually the trickiest. You've got to write down the right sort of starting equation or starting expression between the 2 variables. Okay, don't worry about not understanding what any of this means, because I'm going to do a couple of examples with you in this video. So first of all, you've got to write down the right link. Okay, whether they're proportional or something called inverse proportion, which we'll do next time. Sometimes there's a squared involved, sometimes even there's a cubed involved, not very often. Okay, once you've got the right expression with the fish, you get rid of the fish. I know it seems a bit silly to write it down and get rid of it, but that's what we do. Okay, so you take the fish out and put in an equals k. Then you'll be given some numbers, and with those numbers you can work out what k is. Like when I gave you some numbers to work out the cost of an apple, or I gave you some numbers to work out the cost of 1 litre of fuel. Then once you've got your expression and you know what k is, you can use that expression to solve other problems. Okay, so get that in your book, and we'll keep referring back to this when we do some questions. Okay, pause if you're not ready. I'm going to move on to a question. Okay, and this basically is an exam question. There's no mucking around here. Okay, we'll go straight into it. They're all pretty much the same. Okay, the weight of a box, and we'll give that letter W, is directly proportional to, which means I can use the little fish, to the number of tins in the box. So we would say that W is directly proportional to the number of tins, and then straight away we change it to W equals KT. The fish goes and K comes in, so that goes and gets replaced with an equals K. Then we put in the numbers from the question. So when there are 30 tins, the weight is 60. So the weight is 60, and that equals K times 30. All I've done is put 60 for W and 30 for T. Now how would you work out what K is then? You'd take the 30 to the other side and divide. 60 divided by 30 is K, so K equals 2. In real life, what you've just worked out is that 1 tin is equal to 2 kilograms of mass. Okay, it's not really weight, it's mass. So K is 2. Now, before you go any further, and this is really important because you'll drop a mark if you don't do this, that second line that we wrote down, that W equals KT, now that we know that K is 2, we should write that W equals 2T. And if you skip that line, just finding K on its own doesn't quite get you all of the marks. You have to sort of go right back up and put that number in. Right, now we've got the expression that W equals 2T, we can answer these. Look, so find the weight when the number of tins is 18. So W equals 2T, so W equals 2 times 18, so W equals 36. The weight would be 36 if there are 18 tins. Okay, the numbers are really, really nice. They're not always this nice. Part C, find the number of tins when the weight is 26. So remember, W equals 2T, 26 equals 2 times something. If you take the 2 over and divide, 26 divided by 2 is T, so T is 13. In other words, if the weight is 26, the mass, then there must be 13 tins in the box. And that that there is proportion. The only thing that changes really is that very first line. Depending on how the variables are linked, you can have some trickier expressions up here, and it just makes the workings a little bit harder. But that basically is what every proportion question looks like. You start with an expression with a fish. You introduce a constant k. You use the numbers from the question to work out what k is, and once you know what k is, you have this final expression here. And with your final expression up here, you can answer these questions underneath fairly easily. You've just got to put the right numbers in the right place. Okay, let's have a look at another one. So in an experiment, it is found that the length of a spring, L, is directly proportional to the mass hanging on the spring, M. The more mass you put on, the longer it gets. Okay, that's Hooke's law. You might do that in physics. The length of the spring is 80 centimeters when the mass is 16 kilograms. Okay, so directly proportional to, which means we can use our fish. Okay, worst lines ever. So L, I'll do a loopy L so it doesn't look like a 1. L is proportional to M. So L equals Km. Then you've got to put your numbers in. So our numbers for this question is 80 for the length and 16 for the mass. So 80 equals K times 16. Or 16k if you switch it around, if you don't like having a time sign in there. To get k on its own, you do 80 divided by 16. 80 divided by 16 is k. K equals 5. Okay. What you've just worked out there is that for every kilogram of mass you add to the spring gets 5 centimeters longer. So k is 5 for this question. Don't forget now, you've got to go back up. And instead of saying that L equals Km, L equals 5m. So to work out the length, you do 5 times the mass. So this now is what you use for part B and part C. Okay, so L equals 5m. Find the length when the mass is 13. L equals 5 times 13. 5 times 13 is 65. The spring will be 65 centimeters long. Part C, remember, start with L equals 5m. Find the mass when the length is 35. So 35 on the left, where L is, equals 5m, and we're working out m. 35 divided by 5 equals m. M would be 7. Okay, which makes sense because we said it's 5 centimeters for every kilogram, and 7 times 5 is 35. Okay, direct proportion is not particularly difficult if the numbers are nice. Okay. Now this last one is a bit different. It's got the word proportional to in there, but it's also got proportional to the square of. Now the square of its mass means m squared. So this time I'm not going to say that v is proportional to m. I have to say that v is proportional to m squared. Okay, I did mention earlier on that the starting equation can get trickier, so here's one with a squared in. Okay, so it's not direct proportion anymore. Direct proportion means if you double one, you double the other. When you put a squared in there, that's not true anymore. So it's not directly proportional to the square of, it's just proportional to the square of. Okay. Everything else now is the same. So I still put equals k instead of the fish, but it's m squared. If you forget the square, this is going to go wrong. Okay. I still put numbers in. So in the question it tells me that when the mass is 3 kilograms, the diamond is worth £2,700. So if I put those numbers in, 2,700 is the value when the mass is 3, but it's 3 squared, remember, not just 3. 3 squared is 9. Take the 9 over, so 2,700 divided by 9, k equals 300. And before we move on to the next part of the question, you still go back up and you still say here that v equals 300 m squared. So that's how you work out the value of a diamond. It's 300 times its mass squared. Find the value of a diamond whose mass is 4 kilograms. So V equals 300 m squared, which is why this is so important. Okay, without this you can't do these down here. So the mass is 4, so 300 times 4 squared. 4 squared is 16, and 300 times 16 is 4,800. Okay, and what happens when you square is that if you make a little change to m, it has a big effect on v, because if you think about squaring, 9 squared is a lot bigger than 8 squared, and 10 squared is even more bigger than 9 squared, and the further you got the gap, the bigger the gaps get. Okay, it's called like an exponential relationship, where a little change actually becomes a big change when you square it. Okay, and then part C then, using the same formula, V equals 300 m squared. This time we know the value, so 14,700 equals 300 m squared. I'm going to have to divide by 300. Divided by 300, okay, let's move that down, is m squared. M squared, when you divide it, you can use a calculator, is 49. The square root of 49 is 7. Now what I would say here is that it could also be minus 7. Okay, but this is a real life question. You can't have a diamond of mass minus 7, so you ignore that one. You don't always ignore it. Okay, if it wasn't about something real that has actual mass, you'd have to write down both answers, plus 7 and minus 7, because minus 7 squared is 49 as well. Okay, but in a real life one, just take the positive answer. We found that the mass would be 7 grams for a diamond with 14,700. Okay, and if I sort of zoom out a little bit, I mean, all of these questions are going to look similar. Look, if I go back, that one, okay, looks pretty much exactly the same as that one. Okay, all of these questions are the same. I'm following the same steps, and it's the steps in that box there. Okay, you've got to get your formula right at the beginning. So if it says directly proportional to, it's just a fish and your two variables. If it says proportional to the square of, it's a fish, your variables, and a little squared as well. And you will have to do maybe some squaring here, some squaring there, and then when you do the last little bit, I actually had to do some square rooting because I was working out what m was. Okay, but proportionality is not as difficult as what you may have thought after yesterday's lesson.